Jason actually recommended this to us in like 721.
Hmm.
Yeah, he was like, it's a good supplement because Dumb and Foot is all text. Like, just definitions.
Oh. So,
I've also had a friend recommend this book.
God. So reading the first section, I learned I was an idiot.
You're
Why?
not an idiot.
Because I didn't know that a set... So, like, it's like the first thing they say is, a set of 1, 2, 3 is equal to 1, 1, 2, 2, 3, 3. And I was like, fucking what?
Yeah, that's true.
Blew my mind how I have a master's in physics with a minor in applied mathematics, and I didn't know that.
Well, it's applied, not theoretical. It's okay.
I
You
can't.
don't need sets, probably.
Yeah. I'm sure there's things that Dakota still doesn't understand about sets.
I have a bachelor's in math, and I fucking didn't know that. And I thought about it, and I was like, oh my god, it's so obvious that that's not a part of the fucking Jesus Christ.
Well, to be fair, there is such a thing as like a multi-set, so
Mhm.
where it does have multiplicity. So I mean,
Is
can't
there
really
a,
fault it that badly.
What?
is there like a set theoretical...
The whole.
Yeah, what about the... There we go. See? Okay.
Oh, some
Dakota,
orange.
is there like a construction of like these kind of sets and from multi-sets
Get it out of there.
with like relations?
Say that again?
So like is there like a construction of sets from multi-sets with relations? Just because it identifies all of the ones and it's like, oh, these are the same thing. But like a multi-set, you can have different ones.
Oh, be careful, Austin.
Yeah, I mean, you can just take any set and identify it with the multi-set where the natural number for each element is 1.
I see.
And then I guess you could go into equivalence relations or something, but it's just like kind of a lot of baggage, I think.
Yeah. I don't know.
And even then you have to like know what natural numbers are, which
Oh.
sort of defeats the purpose.
Oh, that's sad. Good thing for category theory.
I also learned
I
about...
don't think
Go ahead, Dakota.
I don't think multi-sets are even like used in anything I've seen, at least not yet.
They're in, well, maybe not set theory, but we use them a lot in combinatorics, if I remember right.
Yeah, they're...
I mean,
part
like
of
in the
combinatorics.
textbook that we're reading.
Oh, okay.
This guy kind of has like a lot of like recurring exercises that involve you making up your own category of multi-sets, but that's pretty much it.
What do you think of the discussion of disjoint unions?
I did not know what that was a set operation, so that's where I felt retarded.
I also... I didn't understand it at first, because I was like, oh, this is pretty easy. And then he was like, so if you have 2 sets of size 3 and 4, that means obviously the disjoint union is size 7. I was like, what? Apparently I didn't understand this definition at all.
Well, yeah, because it'll be the normal union of 2 disjoint sets that have cardinality 3 and 4, so it's going to be cardinality 7 because they share no elements.
Yeah,
It's just in the construction you throw in this detail that if the sets you're taking the union of happen to have overlapping elements, you just ignore that and treat them
They could
separately.
not.
The
Yeah,
construction
he
that I've
doesn't-
seen at least is you take like a singleton and then a different singleton, and then for each one of the sets, you just like product it together, so you don't ever change the set, and you can just identify them.
Yeah, so the sets the elements are considered ordered pairs with like 0 and 1, either 0 or 1 attached, and to distinguish the same elements, they change the first part of the ordered pair.
Where the hell is my copy of this book? There it is.
Didn't you just make it? You're like, where did it go?
Dakota spent like 20 minutes making coffee and it somehow just vanishes.
It's like,
No, I know where my coffee is. It's right here.
Is that your giant mug?
Yeah.
Awesome.
Here. Can I like flip this around so that it's the other?
Can we
Camera?
tour your apartment a little bit?
Why?
Because I want to know how you live, Dakota.
No, not well.
Thank God I don't have to do that. My apartment's a pigsty right now.
I just
Okay,
my
so,
Neat.
so here's that's my front door. I have the
Okay.
European Union flag over it, and then I have like big windows, and there's an air conditioner that I bought.
Nice.
And
Wait,
they
you
put it
bought
in
that?
for me. That was nice. Yeah. And then, and I get to take it with me when I leave, which is cool. Here's my bookshelf. There's books on it,
Cool.
and also board games at the bottom. There's Kramer. Kramer's there. Austin, I had that in my room when I lived with you.
Yeah, you
There's my
did.
whiteboard. I have a whiteboard on the wall. And then here's my TV. I'm looking at BD right now. And here's sort of where I sit. And here's my tiny kitchen.
Cool.
I have toilets on the fridge. And I mean, yeah, but you can see how it would like get super cluttered if I filled it with a bunch more stuff. Like I don't even have a microwave
I see.
because where would it go?
What do you use the microwave stuff?
He doesn't, honestly. He doesn't do that.
Yeah, the
I
broiler.
either heat it on the stove or put it in the oven.
Oh my God. I guess microwaves are micro. Wait,
That-
fuck.
What are you gonna say, Austin?
Where
are you going with
please?
There's the bathroom, and here's a shelf with junk on it, and then I didn't make my bed, I'm sorry.
It's okay. I'm not recording your apartment.
Okay.
Hmm. Is it just audio that you're recording, Austin?
No, I'm recording myself playing Bennett Foddy.
Oh, okay. Screen capture. You using Fraps?
No, I'm using Shadowplay.
Oh, I see.
Did anybody do the exercises for this section?
I
No.
did some of them.
I think I did. Let me pull them up so I can look at them.
First one, locate a discussion of Russell's paradox and understand it.
Oh, I had some.
Yeah.
Where's the
Russell's paradox is kind of funny to me, just
Is
because,
that the-
like,
like the
there's this
set
guy
of
named
sets
Frege
that-
or Frege.
Frege.
There's this guy named Frege who works so hard, like axiomatizing set theory, and then Zermello and Russell kind of at the same time said, "Dude, like, there's a contradiction in the system. You can't do it."
And he was really cool about it because he was about to send it off to the publishers when they told him about this contradiction, that he just tacked on a little note at the end of his book that said, yeah, these guys pointed out some problems with my work. Oh, well, and then just published it as is.
That's cool.
Nice.
So his paradox is the one of like sets that don't contain themselves.
Yep.
Yeah,
Yeah.
so the problem is it doesn't make sense to, given just some property about sets, talk about the set of all things that, or the set of all sets that satisfy that property.
Mm-hmm.
Right? You have to restrict it in some way, because if you don't restrict it in some way, you can ask, okay, look at the set of all sets that do not contain themselves, and then that's a contradiction because the set is in itself if and only if it's not.
Neat.
So
One thing
the
I was-
moral of the story is you need to restrict your comprehension in the way that you build sets in some way.
Yeah, I was kind of amused because in category theory, they want to talk about the category of all sets, but that's kind of similar in language, at least, to talking about the set of all sets. So to kind of underlie category theory so that they can talk about the category of sets, they kind of had to modify the Zermelo-Frankel axioms. I think it's called like the Bernays Gödel or something.
NVG, von Neumann, Bernays, Gödel.
Oh my god. I thought you were going to say something like category theory is basically we renamed sets to categories so that you can't have that contradiction.
Problem solved.
Oh shit.
That's awesome.
Yep. So the thing is, you don't actually need to have a thorough understanding of the set theoretic foundations of whether categories exist or not to actually do what category theory is designed to do, which is add a lot of like, how to say, like structure between all sorts of like algebraic things that in a sort of like unified way.
There's a lot of like mapping properties of if you can find two sets that map together in this way, then you have like a third set made from those two to map to. Like the kernel construction or something.
Oh yeah, the section was talking about that a little bit, wasn't it? We're making
Was
like
it?
a new... I thought it was. It said
maybe.
something you have to get into functions to explain it.
Yeah.
Maybe, I don't quite remember.
Whatever, I'm just...
And you're,
No. It's good.
you can certainly state in ZFC all of the
For the relations.
the important theorems that happen, like for any two, groups such that this one group is contained in this other subgroup, there exists a unique group homomorphism such that yada, yada, yada.
Yep.
Like that, you don't need to worry about proper classes or anything to do. It's just a thing that is true that you can prove.
I was talking more like the structures that you see appear in different levels of like algebra. So you talk about like the kernel of a group, and then you talk about like ideals of rings and so forth. And the same kind of like mapping constructions seem to just pop up, whether it be like groups, rings, or modules.
Mitch, did you see that?
No.
Okay, thank God.
Can I say, Austin, that if you record Getting Over It with Ben Foddy, that's actually brilliant, because as we go through the book, you'll be getting higher on the mountain.
Yeah, we'll
And then you
fucking
can
see
get
if I get
closer to the ocean.
Let's get over Chapter 0 with Lane, Dakota, Austin, Mitch, and Tyler.
And benefit.
Because, man, I was really close to, like... I got it up pretty high, and then I fell, and I got really mad, and I just started swinging my hammer, and I clipped an edge and almost fell back to the beginning while I was angrily swinging my hammer.
Yeah. I hate, if I can say, just because I've had bad experiences with equivalence classes a lot.
I had
the
troubles with that
relation
when I
section.
was in 270.
Yeah,
I had a lot of trouble
they're
with it.
tough. Like they're hard to sometimes dissect your like. God, I can't even talk straight because I'm thinking about equivalence classes. Yeah,
I remember that was the thing I had
I
to
love
study.
equivalence classes.
they're fine until you have to start making maps from an equivalence class to an equivalence class, and then you're like, okay, is this map well defined? And it's like, let's look at the projection
Austin.
map.
Just put it down and then swing. Okay.
Careful of those
I
ones.
guess I'm too retarded to have encountered any exceptionally difficult examples. But
It's the very last problem on the homework that I sent you is actually an example where you have to prove well-definedness and openness using like the weird mappings of equivalence classes.
let's see.
Yeah. Can you draw on Google Hangout?
I don't know.
I was
Never
under the
tried.
impression that you could like put up a drawing thing.
You could like pull up MS Paint or something on your phone and like cast your screen or something.
Yeah, he's right. I could screen share
Oh,
my
yeah.
MS Paint.
Maybe I'll do that. That sounds like fun. That might be helpful in like trying to communicate things.
I won't be able to see it because I don't have like a second monitor.
Oh, well.
But that's okay. You can still do it. I'll just
Yeah.
focus on my hammer.
Can I control like what window I share?
You can, but I don't. I just did entire screen. Oh no, no. Okay.
Entire screen. Only share screens with sites you trust. Okay.
Austin, are you going to put this on YouTube?
I'm going to try. Tyler and I had a music review YouTube channel, and I'm gonna just like
Okay, never mind.
convert it into a review channel. Oh!
A review channel? What?
Because it was called Austin and Tyler's Music Reviews, and then I'll just like X out the word music in MS Paint or something really shittily.
I'm back again. How's it going?
And then I'll put this on there as well. I might edit the clips. I might edit it down, but I don't think I will because it's.
Are you gonna? What did you say about review? My like tab crashed when I tried to screen share, so I guess I can't do that.
Tyler and I have a music review channel on YouTube. It's just called Austin and Tyler's Music Reviews, and we were doing pretty well with it. We were just going through Scroofy's list, like listening to the album and then talking about them. But then like we recorded like 3, I think, and my audio didn't capture correctly, and so we just kind of stopped. And now we're doing this.
Austin and Tyler's music reviews.
Yep.
Oh, 3 subscribers.
One
2
of us
videos.
Probably Mitch.
It's you guys talking about it while playing Factorio.
Yeah, that's right.
Nice.
Yep.
I really like the first one
kind
with
of vapid though.
the Trout Mask Rapala video. I really like that video. I like how it turned out.
I like that the first thing Tyler says is, you should put in a disclaimer warning everyone that we're idiots.
I did.
Tyler, our IQs are both 71.
Yeah.
That's awesome.
Well, it's not we don't know anything about like composition theory in music, so we don't actually know anything. So it's just like kind of, ooh, we think it sounds like this.
Yeah, that's
pretty much
about it.
It's fun though, but
I was
as far as
actually-
like intellectual content, it's pretty vapid.
I was really sad that the videos didn't work because one of them was really good. We talked about Velvet Underground, and I really liked our discussion of that.
Cool.
Mm-hmm.
But then that one didn't work out.
Did you guys sound like you had 70 IQ each?
No, together.
Oh, together? Dang.
And now we can post this video where we're all talking about math, and people will be like, wow, Austin and Tyler sure are IQ 70.
Yeah, because it'll just be Lane and Dakota talking about some really fucked up abstract shit. And Austin and I are like, so, does everyone know what a set is?
Are you reading Algebra Chapter 02, Mitch?
I told him to at one point, and I don't think he heard me, and now...
Literally
and so I,
never told me to.
you
Literally
and
never
you
told
and
me
Ethan
to.
were in the call with me. We were playing Smite, and I said, join my subreddit in my book club.
In my book.
What?
Yeah.
I never played Smite with Ethan.
He didn't. He wasn't playing.
In the past, like, year.
He wasn't playing. He just joined in and was like, "You guys want to play Siege?" And we were like,
Oh, I didn't hear that then.
"Yeah, I know you didn't hear it because I figured you would do it."
You guys.
Well then,
Whoa, Mitch. Jeez.
Yeah, Mitch, don't get all angry because I didn't invite you a second time.
God, calm down.
well, you were aware that I didn't hear it.
Yeah, you're right.
So in that case, a second invitation would be needed.
Shit. Damn social skills.
Yeah.
Maybe I do have autism from vaccination.
Vaccinated.
That's right. That's like your cousin.
Hey, my cousin has Asperger's from
Oh, I'm sorry.
whatever we're talking about, vaporizations or something.
Vape-
Vaccination.
Vape too hard to go.
That's a little too much.
You'd
To be
have
fair,
a
I
lot
think
worse
anybody that
conditions and
vapes does
autism from getting vaporized.
He's been vaping too much. He has autism.
Getting that sweet vape juice.
They're like doing weird militaristic type tests called vaporization on him. And they're just like, I don't know about that test. I think it gave him Asperger's.
Asperger's.
Asperger's. Oh my god, I am getting so fucking sweaty from this stupid game.
I had to stop because I was starting to get a stomachache from rage.
Shit. No!
Oh, no!
Oh my god!
Get it off!
I almost just flipped over the stupid orange table.
What do you
Got a pogo.
Oh,
what do you guys think of the second problem?
I don't
oh,
think
oh yeah, we're going through. We're talking about the book. That's right.
Oh no!
It says, prove that if squiggle is a relation on a set S, then the corresponding family,
Squiggle.
P squiggle,
Oh,
defined
Austin?
I
in
need everyone to
1.5
look at my screen for a sec.
Is
is everything okay?
Oh yeah.
Oh yeah, that's like a
Partition sign.
standard. Yeah, that's like proving that partitions. They prove. Yeah, that's proving that partitions are pretty much the same thing as equivalence classes.
Yeah.
And that's one of the halves to proving it, and they prove the other half in the text.
Oh my god, Tyler all of a
Is,
sudden got really
is
loud.
this just equivalence relations that partition sets, or because I know that equivalence relations do.
Oh,
Yeah,
Yep,
this is a
equivalence
typo.
relations partition set.
I think it says like 1.5. Is that like chapter? So is that like part 1? Like
That's
definition 5?
subsection 1 and then subsection 5.
Okay.
So there's like subsections to the chapter, and then there's like subsections.
Yeah. Because I know that I was pretty sure that only equivalence relations partition things like in a guaranteed way.
Yeah,
Other relations might not.
Yeah, that's
No,
yeah. I assumed equivalence relation when he said relation because
I see.
otherwise
yeah,
it's
that's
not
he
true.
should have said equivalence relations, so that is a typo. But yes, they are talking about equivalence relations. Then 1.5 is at the bottom, starts at the bottom of page 6.
Sorry, bottom of page 6. Oh, okay, I just missed it. There it is. But that's so that's actually like a really cool result, I think. Like even though it's very basic, because it leads almost directly into Lagrange's theorem in algebra that says like if you have a finite group, the order of any element in the group has to divide the group. Because you can define an equivalence relation that partitions it in such a way that the order of the element times the equivalence classes, or like times the number of equivalence classes, is the total order of the group, which is super cool. Like, it's actually a really important property.
Yeah, so basically partitions of a set and equivalence relations on the set are exactly the same thing,
Yeah, it's super cool.
That's cool.
is what this problem is saying.
Yeah.
If only I wasn't dead inside.
Sorry, Austin. The union class. Given a what about number 3? Given a partition on a set. Oh yeah, every partition is in some sense a relation on the set. That is also a pretty cool thing.
What, Mitch?
That one's
I
pretty
just
easy.
need you to
Like,
fuck
everything
off
is
for a
partition.
little bit.
Yeah, I mean that's just the other side of the 1.2 pretty much.
Mhm. It's cool
Here's
that it's an if and only if statement,
the
though.
bane of my existence right here.
Or like kind of an if
Yeah.
and only if statement, I guess. Got a relation, it's a partition. Got a partition, it's a relation. Don't worry about it.
Yep. Oh, you did
And
it.
the actual details are, given a partition, define the relation to be two things are related if and only if they're in the same part of the partition,
Yeah.
and then you go through the machinery of showing that that's actually an equivalence relation.
Have you ever tried to work with like relations and functions on sets as just being like subsets of those things? Because I know that like a function is technically a subset of like two sets x and y of their product, right? So if I wanted to,
Yeah.
I could just define a function using that subset thing. Have you ever tried to like go through and try to prove something and not use the like convenient notation that we've developed throughout the years, but do all this like subset stuff?
There's a few occasions in studying, like, axiomatic set theory at the very, foundational level where you have no choice but to do that. But in doing, real mathematics, no, I've never had.
I decided to try and understand what a group would be if I just considered it as subsets, because a group is G and it's an ordered pair G, and then a map which defines multiplication, but that map is from G cross G to G, so a group in total is G as well as G cross G cross G. And I was like, maybe I don't want to prove anything on this anymore, so.
You need to use that sometimes in first order logic. Is a function that takes, say, n inputs and gives one output is the same as a relation. So not a binary relation, but an n plus 1 array relation is what it's called.
Okay.
Because you just have
n objects and then one output.
Yeah.
Yeah.
Just your output is the n plus 1 tuple in the relation.
Neat. Can you have an mn relation where you relate m to n things? Or n things to n things, I'm guessing?
Yeah, so what is an n-array relation? It's just a subset of whatever space you're talking about to the power n. Mm-hmm. So it's just a set of n tuples. And this tuple is related if they're in this set. And they're not if they're not.
Huh. That's pretty cool. It seems like it gets really hectic.
Yeah, first order logic does it in a very different to category theory, but similar in spirit, unified way of considering one system that encompasses groups and graphs and all this sort of stuff. There are certain things it can't do, but
neat.
But there are a lot of things it can do.
Austin, what do you think of equivalence relations?
Pretty good. I really I don't have super smarts to say about it, but I do know that your first introduction to equivalence relations is usually through modular arithmetic, which is talked about in the book.
Oh yeah.
And that's what I remember using it for, because I remember modular arithmetic being something I really struggled with at first, and now I got it pretty well, I think. Probably not, because I actually haven't been using it too much.
So I feel like conceptually it made a lot of sense when you first learned about it, because you're like, of course, it's just plus 3, and then they're related. Duh. They're the same mod. But then, using it in proofs was really hard.
I've actually been using modular arithmetic a lot. Oh, no, not again.
Austin, I saw that. Austin, you fell off the car. Oh, no, Austin. Oh, Austin. Oh,
baby.
I just did that 2 times in a row.
Well, back up the mountain.
I gotta get over the
God, dude. Holy shit.
That's so fun. Good.
But yeah, I've been learning Python recently, and
oh really?
And some of the I just found a website that's Python activities for beginners, and some of the activities are write a code that finds all the factors of a number, and you can use modular arithmetic to figure it out pretty easily.
Cool.
And so I've been experiencing that again. But what always screwed me up was the notation for equivalence classes on modular arithmetic. It would be 0 or 1 if you're doing mod 2.
Mm-hmm.
That really fucked me up when I was back then. Back in the 4th grade. However long ago that was.
Austin, I didn't learn about modular arithmetic until I got to my 3rd year of college.
That's actually not true. You probably learned about in
it modular arithmetic.
Yeah, you
learned about remainders.
Clocks?
Yeah, clocks. You learned how to tell time a long time ago. And
not in a really formal setting. I would have never thought about things this way until
your parents didn't sit you down and talk to you about modular arithmetic.
Yeah, right after they talk to you about sex. Come on.
The inclusion property. I'm oh, okay. How many different equivalence relations can be defined on the set 1, 2, 3?
I wasn't sure on that. I thought it'd be like n factorial or something.
Oh, it's the
number of ways you can
partition.
partition this set, because from parts
Oh, that
questions
makes sense.
1.2 and 1.3, an equivalence relation is just a partition, which there are 4 ways of doing that.
So it's 2 to the n, basically. Wait,
No, not necessarily.
it's 2 to the n
That-
minus 1?
That gets to be a
No,
really hard
there's-
problem if you get a larger set.
Yeah, there's not actually an explicit formula for it. It's like one of these famous unsolved problems in
Really?
combinatorics.
Yeah, yeah.
Oh,
Wait,
that
Like,
makes sense.
how many different ways of partitioning, like, n things are there?
It's the
But yeah,
it's the same thing as like how many
That's
non-negative
an unsolved
integers add up
problem.
to something or something like that.
Yeah.
Yeah, very hard problem. So
Wow.
But yeah, the only partitions of a 3 element set are, there's the one where they're just all elements are equivalent to each other,
mhm.
and then there's 5. So there's the one where
Jeez.
elements are only equivalent to each other, or themselves, I mean, and then there's the one where 1 and 2 equivalent but not 3, one where 1 and 3 equivalent but not 2, one where 2 and 3 equivalent but not 1. So there's 5.
Huh.
Let's
Well, I feel retarded now.
no, it's okay.
I was mixing up power sets.
Okay.
Yeah, yeah.
Because you have to make sure all of these things do not intersect each other, because partition.
Let's go through and all give examples for the next question. Give an example of a relation that is reflexive and symmetric but not transitive.
Less than equal to? No, that's not symmetric.
And it's also transitive.
That is transitive. It's also transitive.
You changed the
Okay,
question
so
wording around a bit,
that's why we
right?
call it retard club.
Is no matrices? No, that's not right. They're not symmetric.
What?
No,
What?
nothing.
How-
Shut up.
Are they a relation? What do
No,
they do?
no, shut
I
up.
wanna know. It might be insightful.
I was thinking of like matrix multiplication, but that's a
Yeah.
little specific.
They're
isn't
in
it?
general, not community.
Oh, okay.
Yeah.
Well, they're okay.
Well,
Is that what you were thinking of, Austin?
Yeah.
Getting influenced by that Sakurai.
A non-transitive thing. Well, there's like, there's the there's like posets you can make. So then transitivity isn't necessarily true. I don't quite know how to make a poset offhand, but
I think I have a graphic example.
yeah.
I think
that'd
I
be
just
cool.
glitched out right there. That was weird.
Oh yeah, Dakota has a whiteboard. That's fucking awesome.
So define x total y, and only either x equals y, just to automatically make it reflexive, or, I'll use the or symbol, or say you have like a graph.
Yep.
Like 2 vertices are equivalent if either they're equal or they have an edge between them, x and y have an edge.
Yeah, that's a good one.
It's reflexive because if they're the same, then obviously this is true. It's not transitive because, you know, this vertex and this vertex are equivalent, and this are equivalent, but not this and this.
Yep.
wow. Nice.
And it's symmetric because, obviously it is, because graph.
Graph. Nice.
Am I showing it right? Oh yeah.
So this won't show up in my video. Do you want me to switch off for a sec or something?
I could take a picture and like send it to you, and you can splice it in
Yeah,
post.
Yeah, that'll work.
That'd be cool.
I'll just splice it over where we're talking right now and just
Dakota's face is frozen.
give a big old like peace sign. Do a double peace sign with your tongue out when you take the picture. Yeah?
Oh, fine. I can't because I need one hand to hold the phone.
Fuck. Well, it's not even. I don't know if it's worth it.
Oh, no, hold on.
I stuck on?
The chair.
God, stupid chair. There's chairs all around me. Well,
Okay.
It's true, you can sit on anything else.
do you know, Mitch, that when I first did this, I didn't even notice the hole, and now I'm so scared that I think I fell. Shit!
Just don't think about it. Just don't think about it.
He did it. He fell.
Nice job, Austin.
I fell right through the fucking hole.
What's the last question say? Define
No,
a relation
no, hang
on
and
a
drop,
set-
no.
Oh my god. By setting A equivalent B
Oh.
if and only if B minus A is in Z. Prove that this is an equivalence relation and find a compelling description of R mod this equivalence relation.
Can you say it again?
The equivalence relation is on the reals and two numbers A and B are equivalent if their difference is an integer. Okay, prove that it's an equivalence relation and then find a compelling description of R mod this relation. So what does it partition it into?
So it's really easy to prove that it's an equivalence relation. And as far as its description, I think of it as like the set of orbits that consist of unit intervals. If that kind of makes sense, I don't know.
The set of that has like integer
It's like the
intervals.
set of all sets of points that are unit intervals apart, going all the way up and down R. That's a really crappy description.
It seems like all the irrational numbers are like so all of the integers are related
Yeah.
to each other. Let's see, and then everything else is only related if it's some integer multiple.
It's like you
Obviously.
take this set of integers and shift them. Yeah, it's like a shifted set of integers.
1/2 is related to 1.5 is related to 2.5, and so on. It's a circle, basically. Right? Because if you think
A
about it,
circle parameterized by the unit interval,
I
essentially.
see. It's the from 0 to 1. Everything is equivalent to something in that interval,
yeah,
and then 0 and 1 are considered the same. That's pretty cool.
it's the group R mod Z is what they're describing here,
Yeah.
which
Do the
is a
same
circle.
thing. Okay, so now it says do the same for the relation on R cross R, defined by declaring this thing, which it's the same in each slot. Okay. So that
Yeah,
would be
this
like
is just
the
a
chorus.
shifted grid of integer values, pretty much.
Yeah,
It's
just the
the
torus.
group R2 mod Z2, which is a torus.
Cool. So, are they trying to get at they're like having these descriptions via set theory without having to go into detail of like groups or topology or something to like define them?
Yeah, it's showing that you don't need like to know what a group is to be able to define like a quotient group,
Oh, cool.
Guess you can't get past the
even though that's
paddle.
really what they're doing.
Yeah.
Oh,
That's neat.
guess who's stuck at the paddle?
Well, that was enlightening.
Paddle's easy. There you go. Oh, there you go.
Okay.
That was fun.
Oh, Austin.
Yeah.
I didn't know how to send the picture in Hangout, so I texted it to you.
Yeah, I saw it. I'm not surprised by what I got, but I'm a little disappointed.
I gotta see.
It's just like a shitty drawing of you with your two-piece sides and your tongue out. Like,
Well, what was I supposed to do, huh?
I don't know, but you said you could do it.
He did it.
Good.
Nice. Okay, time to get.
All right, so talking shop. Does this time work for everybody every day?
like
Or not every day, every
Yes, because I'm
Saturday.
unemployed.
at around Austin. Okay. Okay, we get it, but like, come on, man.
My career is locked behind a look back.
your career is locked behind. Like, once you get over this hill, don't worry, it'll come through.
Don't worry. One of these loot boxes will have a holographic career in it, and then it'll be scot-free.
And then you can sell it.
Oh God.
But I think 3 o'clock on Saturday works pretty well.
Okay.
Yeah, it
Alright,
works
and
for
if
me,
it
but
doesn't,
like
just
Keep talking, Dakota.
most Saturdays, I have a thing at 6:30. Not today, probably, but for most days of the semester, or most Saturdays of the semester. So
okay.
this can't go longer than like 3 hours. If
I don't think.
or I can't do longer than 3 hours
No, that's
if
fine.
we do.
Okay, so
Saturday,
is just one is the one subsection fine every time then, so we don't have too much
Yeah.
content to talk
Especially
about.
because I'm going to be really busy with my homework, so I probably won't be able to get through more than just like one subsection at a time.
Yeah, one section's fine because I'm retarded.
Yeah.
Austin, you're not retarded.
That too, for me, to be honest.
TBH, bro.
God, this cup is driving me nuts.
All right.
It's
so
glitching
that
out. I
sounds
don't know if you
cool.
can see
All
it.
right.
Cool.
I'm gonna stop the recording.